Okay, that's no problem. Shoot me an email.
Yeah, I was gonna say, what was that email address?
So, hold on. I'll just bring it up in the syllabus. That way you. It's right here. It's in the syllabus too. If you just click. Oh, that's right. You don't have access to the class. I'll make this large. Right here.
Okay.
When did you send it? This morning?
That was like 2 days ago, or 3 days ago.
Send it again.
Okay.
Yeah, just send it to that address with CC your counselor on it, because that's who it has to go to, right?
Who?
Your counselor.
Yeah, yeah.
And then I'll just do a reply.
Okay, awesome.
Can I close this? Did you already copy it down?
That should be good. That's the one I think I sent you earlier.
You want to just take a picture? So is the fail safe. Okay. Okay, go ahead and get set up. We're just gonna kind of have a random day, I guess. So I don't want to put out the new assignment just yet. We'll do that next class. I think most people already probably finished this assignment. Show of hands, how many people already finished assignment number 3? Pretty much most people. Okay, so I'll leave a few minutes at the end of class, maybe like 10 or 15 minutes if anybody's still struggling on a certain part of it. Or, I mean, even if you want, I can just go around and check work if you want that as well. What else? Streaming here. Is REPL working out for anybody? Is anybody having any other problems with REPL? Okay. It looks like we actually have I thought it was installed. Open up your command prompts. I swear I saw some computers had Python installed. Does anybody have it installed in command line? No? Okay. Yours does?
Yeah. I'm on the insider build, so.
Okay.
Yeah, it just opens up a link to the store page.
Oh, okay. That's fine. We'll keep on using REPL.
Microsoft said that they were going to release a terminal.
What's
Yeah,
that?
It's on the store too. It's just a preview right now.
Oh, I've heard about that. So, yeah, because the cmd.exe is terrible. And then what's that one, Commander or CMD or whatever? That's when I'm in Windows. I'll use that one sometimes, but it's kind of a pain that you have to download a whole nother. So they're releasing the one that's not terrible. Does it have a name?
It's terminal.
It's just called Windows Terminal Preview.
Okay. Huh.
But you gotta do it off the store.
Okay.
It's going to be part of one of their
Might be a link on the GitHub.
I'll check it out when I get back to my office. That's kind of interesting though. Yeah, the toughest part about Windows, working on Windows, is the terrible consoles and terminals. Microsoft's really turned around. I remember 10, 15 years ago, like they wanted to have nothing to do with open source, nothing to do, basically it was their products or the highway, and they've really turned around. Visual Studio Code is open source and it's written in like a framework called Electron, which is like JavaScript, or it might even be TypeScript, but they would have never done that 10 or 15 years ago, like a multi-platform code editor. .NET is all open source and it runs equally fast on Linux, Mac, and Windows. It runs equally well. It's not like it's like some kind of half-hearted version on those platforms. What else have they done? Oh, their Azure service. I didn't realize this. I don't know if this statistic is still true, but when I read this a couple years ago, they actually have more. They're running more Linux VMs on Azure than they are actually Windows VMs, which is really interesting. They've really done. And now, how many people have done WSL? So it's basically you can go in their store and download Ubuntu, or actually they have several Linux distributions. So they've really turned around. I think it was their old CEO, like Steve Ballmer. I think he's the one who really hated open source and Linux. I think their new CEO kind of, I don't know. I'm really bad at predictions, but I'm sort of suspecting that Windows is really expensive to maintain, and they probably don't make as much money on Windows as they once did. They probably make much more money on Azure and Xbox and Office and all these other things, but I think just regular copies of Windows. So it really wouldn't surprise me in a few years if they, I mean very long term, if they just got rid of Windows and made a Linux distribution or something like that.
All these major tech companies want to sell their business as a service rather than a product.
Yeah, exactly, and that's why I don't think maintaining Windows is that profitable. But if you can get rid of the operating system, that's exactly what IBM did. IBM used to make operating systems and all these other things. Now IBM pretty much, the way they make their money is through consulting and cloud services. So, but anyway, okay, Python. Let's stay focused. Okay, so this is due today, but rather than overwhelm you with assignments, we're going to do the midterm in 2 weeks. Don't stress over it. I'll give you a lot more information in the class before, but how many people have taken a programming exam with me before? Like you took COP2030 or something with me? Okay, so some of you have an idea of how it works, but it's not going to be multiple choice or short answer. You're going to actually have to write code, but I'm really lenient in the fact that I let you use old code examples. I try to make the actual problems for the exam very related to your homework assignments, so it's not like a huge stretch. So it sounds harder than it is, but still study obviously, but don't freak out that you have to write code under a time limit. Okay. What I wanted to do this week is, a lot of times I'll do these little examples that kind of lead up to an assignment. Today there were just a lot of random topics that don't really lead specifically to an assignment, but I think they're useful things to know about. So that's what today is going to be. Today's just going to be a lot of random examples. They're not going to be like complete programs. It's just stuff. We'll tag today's lecture. Stuff Chris thinks is important. Okay. So let's go ahead and not lectures, resources. Is everyone set up? Where did we go? Okay. This isn't super great. We're dropping a lot of frames. As long as I guess it still has the audio, I guess we're okay, but this is a little concerning. Well, I always post a code example. We'll see how it goes. Okay, so we talked about a list. Actually, let's not do this. Let's do random numbers. 11, 14, -7, 0. Let's talk about all the different ways to loop over that list. So the simplest, in my opinion, is for item in my list, print item. This is the most common usage of looping through a list. Because and just as a review, what happens is that it kind of takes each slice of the list, and it's a little bit more technical, but basically it assigns that value each time through the loop. So the first time through, it's going to assign 11 to item. The next time through, it's going to assign 14. Next time through, it's going to assign -7 and 0. And then we print it each time through. Well, there may be times where you want to know the ith offset. So remember we could do this. Remember we could say my list like 1. So sort of like the do that in a print. Sort of like in C++ or C when you have an array. Remember, these are zeroed offsets. So this is going to be your 0th offset, first offset, second offset. So if I go my list 1, it's going to go 0, 1. Now there are certain times where you may want to do something like this. I might want to say, okay, I don't want to loop through for item in my list. I might want to say for I in, and so keep your code. Let me just take a step back. Remember we talked about this function called len? What did this function len do? So what'll this print?
The number of items in my list.
Exactly, yeah. So not the items, but exactly the number of items. And so what specific number will this print?
4.
4, exactly. Because I have 1, 2, 3, 4 items in my list. So knowing that, what I can do is, knowing I can have the square brackets, and I can actually get the length of the list, there's a special function called range that what it does is it does 0 up to that number. So what I can do is for I in range for the length of my list, and I realize this is nesting a lot of functions. But let's just start off doing this. So we'll just print I. And so we kind of work from the inside out, is that we've got this function called len mylist, which will return 4. And we're saying range of 4, which will return 0, 1, 2, 3. Why? So a couple questions. Why didn't it return 1, 2, 3, 4? Yeah, exactly. We've got a 0th offset. So returning 1, 2, 3, 4 wouldn't be that useful. And remember, it's up to but not including. So it's not 0, 1, 2, 3, 4, because that would actually be 5 items. It returns 0, 1, 2, 3, which is going to be 4 items. And we run this, and we'll see 0, 1, 2, 3. Perfect. So another way to print in this list is that what we could do is we could say print, and then we've got our list, my list, I. Now this may seem like a really complicated way to do it when this is so much more elegant. And I will admit, if I had to make up a number, just a random made up statistic that probably isn't true, this method right here is probably going to cover about 80% of your use cases. So why might I want to use this? So let's think of a scenario. Imagine I've got some very, very long-running task that can run multiple days. And this is actually not that uncommon in data mining, which Python is actually very useful for. I've used this in this specific case. Is that imagine I've got some sort of database with 100 million records, and each record takes a few fractions of a second, let's say like 30 milliseconds to process. Well, that's going to take kind of a long time to process. So what I probably want to do is I want to know where I am in the processing. So what you might want to do is each time through the loop, print I. Does that make sense? So you can actually see which record you're on. It almost acts kind of as like a progress indicator. So that might be a usage of it. Now this is actually kind of messy. And it's like, it'd be nice if there was a way to combine these two into something a little bit cleaner, and there is.
What if you didn't want to print every single iteration?
I didn't want to get into that, and in practice you don't, because each print is going to add a little bit of overhead. So what I usually do is I do like I mod 10,000, and then that way it'll tell me every 10,000 times through. So you can, I don't want anybody to get confused by this, but what you can actually do is like if I mod 10,000 is equal to 0.
I was just giving an example of why you probably want to go through every iteration of the list rather than the list element.
What's that? Say it again.
I was just trying to give you an example of why you'd want to go through every iteration of the list
Mm-hmm.
instead of the actual contents of the list.
Oh, yeah. So, okay. But we can actually combine these into something a little bit simpler. And there's a function called enumerate. Hold on. It's going to be the number first. And so what we can do is we can say for I, comma, item, and then we call this function called enumerate. I had to look up the syntax because I always get it backwards. I didn't know if it was item and then I or I and then item. And then this gives us the best of both worlds because now I can get I and I can get the individual items. So this is, to me, this is a much cleaner syntax than something like this, than always having to use the square bracket notation. So I don't find myself using this very often anymore. The two choices tends to be, this is going to be like your default, but there are times where we actually want to know that ith offset to see how far you are in there. And so this is kind of something useful. Okay, any questions on this? And again, I realize some of these are a little bit out of context, but again, it's just like random stuff. These don't really lead into a program. These are just like little things you'd use in a larger program, if that makes sense. Okay, so let's open up another REPL. Let's talk about something called slices. Actually, let's do this. I think I have a good way to introduce this. Now, this takes a little bit of extra work. So inside of REPL, let's go to Files, and then let's add a file. And let's just very generically call it data.csv. How many people have heard of a CSV file before? Yeah, exactly. So it stands for comma separated values. And let's make one real quick. So the first line is typically a header, but we'll skip that for now. And let's say, for example, I've got a very simple CSV. Let's say that the first part is the person's name. We'll just say last name. Then maybe their GPA. Yeah, will give me a lower GPA. That way I don't seem so confident, overconfident. So we've got the name, the GPA, what's another, whether we're a junior, senior, and so on. Okay, and let's say, for example, I'm a junior. That's good enough. So let's fill that out for a few other values. Smith. Okay, 3 should be enough. Oops. Too many commas. Okay. So everyone's good. You have this CSV file. It's separated by commas. And we could obviously add more data, but you get the idea. Now, you had mentioned spreadsheets. This translates very well into a spreadsheet because we've got rows and we've got columns. Okay, so the first column is going to be the name, second column is going to be GPA, third column is going to be what year they are. So now let's go back over to main.py. py. So there's a function that lets us read files. It's called open. Now the syntax for doing this is a little bit weird. So there's a function called open, and then we say the file name. So the file name is going to be data.csv. We can say f, and let's see if, I think we might be able to just do printf. No, so we're going to want f.read. So what we've done here is we've opened up a file. We've assigned it something called a file handle. So here it actually hasn't read the file. It's just basically, it's kind of giving it exactly that. It's what's called a file handle. It's kind of giving you access to that file. Then what we've done here is we've read the entire file. And then finally what we need to do is we need to close the file. Okay. Now this close is a little bit less important in a small program like this because the operating system actually naturally closes the file. But there are times in a long-running program where you want to open the file and then close the file. But it's just generally good practice not to leave resources just out there like this. So this is okay, but here's the problem is that we've read the file all at once. Now, this may not be the thing that we necessarily want to do all the time, because imagine a gigantic file. That's all, when we call read, we're putting that whole file inside of our memory. And that's not really a super efficient way to do things. So what we can actually do is we can read the file one line at a time. So there's a related function called readLine, and that'll actually read it one line at a time. And notice that it just read this first line. So that's sort of useful because now I'm only reading the file one line at a time. I only have to deal with a few bytes of information. Versus, you know, if I have a 1 gig file or something, I don't have to put the whole thing into memory. Does that make sense? So in small files, it's not that big of a deal. I actually find myself just calling read all the time on very small files. If I know the file is going to be very small, which on average they are, but it's not uncommon to come across a very large file. So we want to read this one line at a time. How might I do that? What construct of the language do you think I could read all the lines one line at a time and do something with them? Perfect. Put in a for loop. So what we can do here is we can get rid of this and say for line in f.readLine. And what this is going to do is one line at a time, it's going to go through. And what's great is at most we'll only have a few bytes of memory. Didn't like that. I think we might have to put the separator. Actually, I'm going to come back to this in 1 second.
Wouldn't you just put just F since you're just reading?
Actually, I think we can. I think that's the issue. So just to let you know, this thing is called a generator. And so what we can actually do is we don't have to specifically call readLine. We can actually just, and this will naturally give us one line at a time.
Because I think what you did is you actually took each character.
Yeah, so I read a line and then I asked for each character. Exactly, yeah. So why is it printing like this? So just keep in your head that what we're doing is just naturally this thing called a generator. It wants to give us one line at a time naturally. So it's almost like we're calling that readLine function. But the specifics of the language, what we were doing is we were getting a line and then we were trying to iterate over each character. But anyway. So here we're getting one line at a time. What little invisible character do we have at the end here that we don't see? Exactly, yeah. So our new line character, our little \n thing. So what we can do is there's, by the way, you'll notice I'm calling functions on things called objects. We'll get into this later. But line, we have line is a string. And so what we can actually do is we can call functions on the string. Does that make sense? And there's a function called strip. And what this does is this strips away what's known as white space characters. Let's see if this has a good description if I hover over it. I think as I'm typing it, it'll give it to me. Let me try this again. Dot. There we go. Okay, so prints the values to a string. Okay, whatever. So by default, it strips out what's known as white space. So spaces, tabs, and new line characters. So by calling this strip, and this is on both ends, they have three versions. They have L strip, which strips it from the left-hand side, R strip, which right-hand side, and the strip, which is both sides. You'll most commonly use strip. And then notice print naturally adds a new line, but notice that we were able to get rid of this. So that's cool. Now, because this is such a common thing, we kind of don't want that extra new line at the end. The reason we had that new line is because in our file, as soon as we hit the enter key, it added this. So if we were actually to look at this in a text editor that supported it, it would actually show us there's an invisible new line character here. And so that's what we were getting rid of over here. Yeah?
So you said that strip function is supposed to remove all the white space.
On left and right side. Not in the middle, just on the left and right hand side. There's another function called replace that we might actually explore a little bit.
Is it better to get rid of the white space in the data, or what about if you just get rid of the white space in print?
So there's two different. So what this does is this actually returns a copy of the string, so it doesn't do it in place. And so what we're doing here is that a lot of times, the very first thing I like to modify the original because it's rare that you actually need that extra new line at the end. So this is like anytime I find myself, this is almost the very first thing I do instead of when I'm reading a text file. So that's cool. So now we have the line. We're reading our text file one line at a time. With CSV files, what if I wanted each individual part? So I said line is, and remember we talked about this, just as a reminder, it looks at the right-hand side first, so it's going to take that line, it's going to strip off the extra white space from both sides, and then it's going to return a copy over here. So now if we were to print line, okay, notice that when we call this function, it didn't modify the original, it returned us a copy, and we stored that over here. Does that make sense to everyone? Okay. So there's another string function here that's pretty useful. It's called split. And what this does is, let me just kind of off to the side here. You don't have to type this, but let's say, for example, I've got this. So I've got s equals I'm going to get rid of this in a second so you don't have to type it. And so what split expects is a character. And what this does is it splits the string into multiple parts at every character. And so since this is a CSV, comma separated values, what we can do is just say, hey, split it at the comma. So we run it. We're not going to see any output. But let me do this. Let me store the result. And now let me print result, see what result looks like. What data type do you think result is?
No way.
Yeah, exactly, a list. Because we see the square brackets. So now this is cool because we can take this and then each time through here, we can say, okay, here are the various parts. By the way, don't avoid words like list because that's a reserved keyword. If you see a variable name that you've created and it's blue, that's reserved. So I like to use the name parts a lot. So say parts is going to be line.split. And let's say I just wanted to print all the GPAs. So if I just wanted to print the GPAs, which part am I going to? It's going to be part, exactly 1. So 0 would have been the name. Oh, and it's plural, sorry, parts. Exactly. Yeah, let's do that. That's kind of a fun thing. Now we can't quite do that just yet. What problem do we have with this? We have a little extra character at the beginning here, just the space. Remember how we did this? Just how our CSV happened to be, and that's why I wrote it like this on purpose. Now, if I've got a string like this, what do you think, little function that we just learned, what do you think I could use? We could use strip again, because remember, I'm not dealing with the whole entire line. I'm just dealing with this part here, because I split it at the commas. And so now here, if I called strip, it's just going to get rid of this at the beginning. So now what I could do is parts1.strip. And now we've gotten rid of the extra stuff. So let's do that. Let's store this in a variable. But now, what problem? So let's say, for example, we take the CSV and we want to find the average of these 3 students, their average GPA. Now, what's the problem right now? What data type is GPA going to be? It's going to be a string. So what do we have to do with this? Convert it to a float. So let's wrap this whole thing here. Now if we look at the data type for GPA, it's a float. Now we actually can do some arithmetic on that. I realize as we get more advanced, we're getting a little bit more into abstract things. But I'll tell you, in reality, I can't tell you how many times I've written some sort of variant of this code. Now, there are CSV parsers out there, but there are times where I've got a file that is not a true CSV, if that makes sense. And a lot of times, I don't want the overhead of a full parser. So a lot of times, you'll find yourself writing some sort of variant of this simple code. A true CSV parser has extra stuff, like say, for example, I had a comma in my name or something like that. It would confuse it. So you put a backslash character, those not how you know. Ours is very, very simplistic. So now let's do this. Let's say total GPA is equal to 0.0. Then we can do is each time through, we can say that the total GPA. So we could do this. We could say total GPA is equal to the old total GPA. But what's a shortcut? Does anybody remember the shortcut that we can do? Let's come back to this. I don't want to introduce too many things at one time. So what we're doing is the first time through, it's going to be 0 plus the GPA. Next time through. Remember we did something like this with finding averages?
Yeah, the shortcut, you can just do
Plus equals, yeah. But we'll leave it like this just to be clear. Maybe we'll do that later. So that got us the total. And if we wanted to find the average, we just have to do average GPA is equal to that the total divided by, we ran into a little bit of a problem. So if I want to find the average, what do I have to do?
You're going to need the length of the list.
Yeah, so I'm going to need the length. So there's a couple different ways to tackle this. We can actually cheat and use enumerate. I'm not sure how I feel about this version, but we'll use this. Because at the end, I should be a valid value for us.
Oh, yeah. And I thought I was a local variable.
Python works a little bit different. So, no, that's not going to work. So we'd have to do like I think it, so I minus 1. Hold on. So I should be 3. Let's see what I actually is. I actually I don't care for this version. I'll tell you why in a second. So it's 2, so it actually, yeah, so it doesn't even go through the, so it'd have to be I plus 1. So what happened is that it goes 0, 1, 2, and we want it to be 3. Yeah, so that's so we'd have to do plus 1. The reason I don't really like this version too much is because this is a little bit fragile. Normally what I would actually do is introduce an external, like a variable outside of here and set it to 0 and then increment it each time through, but this works too. Does everyone see what's happening? Is remember we had this enumerate, and so the first time through it's going to be 0, then it's going to be 1, and then it's going to be 2. But we want to divide by 3, so we have to do is 2 plus 1 is 3, and we take the total GPA, but you get the idea. So this is actually, as abstract as this seems, this is something that you do in the real world all the time. Some variant of this where you have some basic text processing that you need to do, and you need to, say, for example, just find a GPA or find some other thing like that. Okay. I don't want to lose anybody, but I want to give you real world examples, and there's more we can do with this. So thumbs up if we can work with this example a little bit more. Okay, thumbs down if you're a little bit confused and we should start a new example. Okay, so let's keep on working with this. So if GPA was this, let's go through this. So we'll say that name is equal to parts 0 dot strip. I want to get rid of that extra stuff. And then the last thing, what do you call that when they're junior, senior, level, rank? Class? Yeah. Actually, it's funny. We actually can't use that. That's a reserved word. Let's say level. You are right. It's probably class, but it's a reserved word, so we'll just say level. So we'll say that parts 0, 1, 2. Now we can do other things. Let's say, for example, we want to count how many juniors there are. So we can do this. We can say num juniors starts off at 0. And let's break this apart a little bit. So this is this little section right here. Oops, hold on. So this little section at the beginning, that's going to be kind of our cleanup. And then this little section right here will be our various calculations. So we did something with the GPA. What would I do if I wanted to count the number of juniors? What could I add on line 15? So what are you checking for? We've got 3 choices: name, GPA, or level.
The third element, second
Yeah.
element of the line?
Yeah, but because we've assigned it to a variable, so we can actually just use if level is junior, and what could I put here? I could say that the number of juniors is equal to the old number plus 1. Now in Python we don't have plus plus. I don't. Actually, I think they did add it. I don't know now. So what we have to do instead is we have to do plus equals 1. And that's the same thing as saying that we're just adding 1. And this should be 2. Going back to our text file, this should give us back 2 juniors. And let's make this an F string so it's a little bit cleaner. And then that's all we're going to do. It's getting a little bit large and messy. And I'm actually going to shrink this just a little bit so the code kind of fits on the whole thing. Okay. But you get the idea. This is the reason that Python is very popular for text processing, is that we can do cool things like this. Is that we can take this text file. Think about how difficult that would have been writing in C or C++. It'd be considerably more difficult. But now in just a few lines of code, in essentially 19 lines of usable code plus a couple of print statements plus some extra space that we had for readability, we were able actually to do some basic data mining on the CSV file. Okay, would it be terrible if we did one more thing with this? Okay. So we have, I'm going to kind of keep this together. Let's say, for example, we wanted all the names in a list. So what we could do is we could make names and then just make that an empty list. Because maybe, for example, we wanted to do something with it later. And then each time through, so you remember the whole purpose of reading this one line at a time is to save memory. But there might be an instance where like you may want to just grab one single field, and that's what we're going to do here. Let's say that we just want, for whatever reason, we want to store the names. The names are important. We're going to do a bunch of processing with them. We want them in memory. So what we can actually do here is, I'll put this on the top here, I guess, is that each time through we can, remember we had this method called append, and what this does is it in place appends to this names list. So I have my name that I grabbed from the CSV file, and I'm going to append it to this list called names. And now at the end here, I should have a list of names. So if I did print, and I'll just do names, we'll do an F string in a little bit. Yeah.
Is it possible to, when it prints, just space them out so it's a little bit cleaner?
Yeah. There's a few different. Oh, you're talking about these three individual
Yes.
things. What we can actually do is we can hard code the new line character. So it can always do things like that. Same thing up here. We'll do it as an F string. But you can do some formatting with anytime you want to add a new line, you just do \n. There are some functions that can do some processing with lists. And there's a couple that are useful. One is called sorted. So say, for example, right now this is not in alphabetical order. So if I wanted to actually print them in alphabetical order, I could call this function called sorted. And now notice it alphabetized it for us.
Now, just out of curiosity, do you know what kind of sort algorithm that uses?
Not off the top of my head. I don't remember the internals of it. It's definitely something that's going to be like log n. It's not going to be like, like a bubble sort, obviously, but I don't remember what they use internally. I'm going to look it up really quick. Time sort. Oh, no, Tim sort. Because it was invented by Tim. That gets into the weeds. There's an upper limit on how good we can do on those sorting algorithms, and a lot of times what they do is they use other statistical properties to kind of get extra little efficiencies. But now what we can also do is we can actually pass in extra parameters to our functions. So there's an option called reverse, and if we wanted it reverse sorted, we could just say sorted names, comma, and then this is what's called a named parameter. We'll talk about these more later. We just set that to true, and notice it's reversed now. Okay. And that's all I'll do with this example. I don't want to get any more complicated. I just wanted to, this is almost like a cheat sheet that if you found yourself, like say for example, a year from now, and you're like, how do I do some basic text processing? You could kind of use this as your template and kind of pick away at whatever things were important to you. Realistically, I don't expect everybody in here to understand all of this code, but it's more like just to kind of expose you to it, that this is what a real world Python program might look like. Obviously, this is a little bit messy. We'd clean it up with comments and stuff. Just to make things fit on one screen, a lot of times I'll just kind of put everything, you factor this out into functions and so on, but you get the idea. What else can we do? Oh, okay. So I'm done with this example. Anybody need a few more seconds to for me to scroll to a certain spot? How are we doing here? Okay, so let's do one more. Any requests? Since today we're just doing random stuff. Is there a specific task you wanted to do previously? Okay. So there's something that's very similar to a list, and it's called well, there's that. We'll talk about that another time. Yeah, there's actually a few. So we're going to talk about something. I always pronounce it Tuple. I've heard people say Tuple, and there's this big debate about how it's pronounced. The guy from Khan Academy says Tuple, so.
Yeah, I hear Tuple a lot.
What's that?
I hear Tuple a lot.
Yeah, so we'll say Tuple. The basic idea is that a tuple is very, very similar to a list, but it's what's known as immutable, and it has to be the same type. Okay. So let's give an example here. So we'll just say T for tuple. And what we do is rather than putting in square brackets, we put it in parentheses. And let's just do a few numbers here. 3, 11, -5. Okay, so well, let's just run it to make sure it's okay. So it didn't crash. That's good. Let's print its type. You can see here it says that it's a tuple. Perfect. But now notice that it doesn't have an append method. It's because they're immutable. Now you might ask, why is this useful versus a list? Sometimes when you're structuring data, you can create all kinds of very complex data types, but sometimes you just want to keep it simple. We're going to talk about things later called classes and dictionaries and all these other things, but has anybody programmed in Java before? Okay, so Java is notorious. Let's say, for example, I had GPS coordinates, latitude and longitude, something very, very, very simple. If I wanted to structure that in Java, what do you think? What's the most common thing you think I'd do? What's that? If I had GPS, so I had the concept of a GPS coordinate, and I had a latitude and longitude. From a data structure point of view, what might I do with that? Well, so in Java, the norm would be to create an entire class, to create two fields inside of that are private, create getters and setters. It has its own file. Sometimes you want to just keep things simple. And that's what tuples are very nice, is that, so basically in like the Java world, for me to do this would be a very complicated thing. And Java's very notorious for that, for being overly verbose. In Python, if I wanted to create a GPS coordinate, I might just create a tuple, and then there's just an understanding that the first thing is going to be latitude, second thing is going to be longitude. So let's say like some decimal numbers. And then now, first of all, we're guaranteed that, you know, this is going to be the structure. Remember, because I couldn't append to it. So I know that, and it's almost more like a, rather than the compiler being aware, this is almost just like a I don't know if there's a technical term for it, just like a programmer's contract, if that makes sense. I'm just saying this is what a GPS coordinate looks like to me, and from now on, this is how I'm going to work with the GPS coordinate. It's not overly structured. It's just me looking at it, and I can use it sort of like a list in that I can say, okay, exactly, same exact thing. Yeah, if I had a box of some sort, I could have a tuple called box and have it have 3 elements. So I'm going to say GPS 0 and GPS 1. Well, Python's unique. So a lot of languages are they have a very small core language, and then they have a very large standard library. So there's probably not very many that it's built into the language, but I'm willing to bet that like something like Java probably has one in the standard library, but it's not like an array where it's built into the language. Okay, so we can use this. The reason I bring this up is, so imagine if, this is a very common thing, is that if I perform a database query, and database queries are going to look very much like this. This is, if I said, okay, get all students from a class, this is typically something, you're going to get a database result like this, where it's going to be, I've got my individual columns, and then I'm going to read it one row at a time. It's actually pretty common that when you're reading from a database and you did a database query, that you're going to get you're going to get a list of tuples. Does that make sense? So what I might do is I might say, okay, let's do this. Let's say, I'll call it points. is equal to, and then let's say I make 3 GPS points. This is going to get kind of messy. Let's make the GPS points outside of here. So we'll say GPS 1. We'll just take these and modify them. You get the idea. So now I've got a list, which is expandable. I can keep on adding things to it, but then I've got these individual tuples. So then what I can do is I can say for GPS and points, and then now what this is going to do is this is going to give me one tuple at a time. So if I were to do print GPS, you can see here that it returned a tuple. And if I say, for example, I just wanted to get the latitude, I can do GPS 0, which is just going to give me the latitude. Does it make sense? So this idea of a list of tuples is actually really common. Now, in more recent versions of Python, they actually have something called a named tuple. I haven't used it really much because I'm just so used to using these plain old tuples. But they actually have it where you can assign these names, which is kind of useful. That way you can actually call it latitude and longitude instead of 0 and 1. I'm still very much used to using the old style way, but if you're curious, you can just Google for Python named tuples. Okay, I think that's enough for today. I just wanted to show you some kind of different features of the language that didn't really feed into an assignment, but is just useful stuff that I've used over the years and stuff that you'll see in practice. Okay. So let's do this. We'll just spend any questions. Okay. So for anybody who still needs a little bit of help on this assignment, go ahead and stick around. If not, if you've already turned it in, you can head out early. And then next class, I'll post the new assignment. And what we're going to talk about next class is functions. Okay. And I think most people in here, how many people remember functions from COP2030? Okay, so we should be able to get through that kind of quick. And then we'll have an assignment associated with that. Okay. I think that's pretty much it. No last minute questions? Okay, so if you're done, I'll see you on Wednesday. Otherwise, stick around and I'll help you out with the assignment.